Right, so without further ado, okay, let's start our class for today. Okay, today we're going to look at module 5. Okay, so this is another assembly language instruction that you're going to learn. Okay, so we're still in the data movement instruction. Okay, but in this module, okay, we are focusing on how to access a memory. Okay, you're going to access a memory to get the data from the memory and put it to the register, to the general purpose register, the GPR, or from register, okay, you're going to put back the data or store the data to the memory. Okay, so now we're going to look what are the instructions that need to be used in order to access the data from the memory and to store the data to the memory. Right, so for the load and store instruction, okay, there are few addressing mode that you need to look at. Okay, the one addressing mode, we call it as a immediate offset addressing mode. Okay, so this addressing mode is the way lah, okay, to store the data or to load the data from the memory. Okay, there are several ways to store and load the data from the memory. Okay, one of them is by using the immediate offset addressing mode. Okay, by looking at the immediate means that you have an immediate value. Okay, so that is what it's spelled by the immediate offset addressing mode. Okay, so let's look at the overview of the load and store instruction before we go more details on the what we call here, more details on the instruction that we're going to use. Okay, and okay, so for the attendance list, okay, please refresh the attendance links. Okay, I hope that after this, okay, you can able to access the attendance link. Right. So load and store instruction are used to transfer data, okay, between memory and register. Okay, load means that you're going to load the data from memory and put it to a register. While what we call here store, you're going to put the data, store the data from register to memory. Okay, it's something like this lah. Okay, we have a register. Then after that, memory. Okay, to get the data from memory to register, we use a LDR, okay, load instructions. Why? To store back the data from register to memory, we use the instruction SDR. Okay, we have in ARM instruction in ARM processor. Okay, there are several instructions for the LDR and SDR. Okay, let's look at the instruction. Okay, to how we're going to store the data and how many bit data that we're going to store and load depending on the instruction that we're going to use. Okay, the first instruction for load is a LDR. Okay, so the LDR stands for used to load a 32-bit word from memory into register. Okay, if you have a 32-bit data, okay, you're going to put the data from memory into the register. We are going to use the LDR. Okay, similar to LDR, SDR used to store 32-bit data. Okay, so 32-bit data, okay, you're going to use either LDR or SDR. While if you have a 8-bit data, okay, we're going to add another character at the end of the instruction called B, byte. Okay, B is stand for byte, means that you know that you're going to load the data, load an 8-bit data or to store an 8-bit data. For if you're using the LDRB, means that we are going to load an 8-bit byte from memory into register, while SDRB store an 8-bit byte from register into memory. Okay, here you can see 0 extended. Why 0 extended? Because our register is 32-bit. Okay, since you only load 8-bit data, okay, the rest of the bit, okay, from bit 8 to bit 31 will be 0 as standard. Okay, you need to fill up with 0, right? And then after that, meanwhile, strb used to store an 8-bit byte from a register into memory. Okay, let's say lah, if you're going to manipulate a 16-bit data, then you need to use the either LDRH or SDRH. Okay, so for the LDRH to store a 60-bit half word from memory into register, and SDRH is to store 60-bit half word from a register into memory. Okay, what about if you have a signed number? Okay, for dealing with the signed number, okay, we need to put a S here. Okay, S stands for a signed number. Okay, so if you have a signed number, to extend the sign, okay, because signed number, we know that, let's say lah, this is a 8-bit data. 1, 2, 3, 4, 5, 6, 7, 8. Okay, the signed number will be at this bit. Okay, so this will be a signed number. If the value is a negative, the sign will be 1. Okay, so how are we going to extend this signed number so that when you load to the register, all of this number will be extended with 1. Okay, fill up with 1. So we're going to use this instruction. Okay, LDRSP or LDRSH, depending on how many data that you're going to load. Is it a 8-bit data or a 16-bit data? Okay, if the sign is a 0, then after that it will extend with 0 lah. Okay, so now we're going to go more details on the instruction, okay, listed in this table. Okay, the first instruction is a LDR. Okay, load register. Okay, so the LDR instruction used to fetch 32-bit. Okay, LDR means that we're going to fetch or load 32-bit information from memory to destination register RD, okay, to the GPR, to the register. Right, so this is the syntax. Okay, we can see here. So you need to know the syntax lah. Every time you're going to use the LDR, the syntax will be LDR RD. Okay, RD is a destination, followed by, okay, so this is a destination, and followed by RN. Okay, so this will be source. Okay, and there will be two two syntax for LDR. Okay, two instruction for the LDR. One is with the offset number, and the other one without an offset. Usually, without an offset, okay, the instruction will be LDR RD followed by RN. Okay, so later we will see, okay, what is the difference between with an offset and without an offset, right? So for examples here, okay, we look at these examples, okay, LDR R0 R1. So what this instruction do? Okay, so the first instruction, LDR R0 R1, means that you're going to load 32-bit number, okay, from an address pointed by R1 to R0. Okay, means that it's something like this lah. Okay, if you have a register, and this is a memory, R0, okay, so this is a R0, R1. Okay, and let's say like inside of this R1 got a value lah. Okay, I put 2000 for example. Okay, and memory, okay, you have a memory and assume that this is an address 2000. Okay, so what happened here is, okay, if you want to execute LDR R0 and then bracket R1, means that, okay, you're going to load a 32-bit number, okay, from address pointed by R1. Okay, so look at the R1. So the R1 saying that, okay, so this is the address. So what the CPU will do, the CPU will locate the address 2000, okay, inside the memory and get, okay, 32-bit number, okay, 4 byte and put it to the R0. This is for the case if the memory is a 8-bit memory configuration. Okay, remember back, we are, okay, in the previous slides, we have two types of memory configuration. One is a 8-bit memory configuration. The other one is a 32-bit memory configuration. Okay, for the 8-bit memory configuration, the next address will be 2001, okay, followed by 2002 and 2004. Okay, sorry, 2003. Okay, since the value here, okay, the data here is only 8-bit, okay, and looking at this instruction, it says that LDR, which is a 32-bit. So what happened here is from address 2000, okay, you need to make it a 32-bit data. Okay, so 2000, 2001, 2002, and 2003, take the value and put it to address R0. So this is what happened. Okay, if you have a 32-bit memory configuration, for example, so this is a 32-bit memory configuration. Same thing, okay? Look at address 2000. Data, okay, the whole value inside of this memory. Because 32-bit memory configuration, okay, the size of the memory is 32-bit. So you all take all the 32-bit data and put it to R0. Okay, so the next address in here it will be 2004 lah. Okay, because this is a 32-bit memory configuration. Okay, so how you going to know that the memory is an 8-bit memory configuration or 32-bit memory configuration? By looking at the difference, okay, between this address of the memory. Okay, if the difference is a 4 byte, okay, you tolak lah. Okay, 2004 minus 2000, and the difference is 4, which is equivalent to 4 byte, means that it's a 32-bit memory configuration. When the difference is only 1 byte, okay, 2001 minus with 2000, okay, then you know that it is a 8-bit memory configuration. Okay, that is for the first instruction. Okay, the second one here says that LDR R0 R1 hashtag 4. Okay, so now what happened here? Now you have an offset. Okay, you need to include, okay, the address that you're going to load the data, okay, need to include with the offset, which is plus with 4. So previously R1 is 2000. So what happened? 2000 plus with 4, okay, equivalent to 2004. Right, so what happened here is you need to go to address 2004 lah, okay. So cari address 2004. Let's say like address 2004 is here. 2004, 2005, 2006, and followed by 2007, for example. Okay, so I put this way. Yang ni is Y, 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 Y. So what happened? Okay, take the this value. Okay, locate the address which is 2004. Okay, and take 32-bit value and put it inside R0. Okay, so this is with the offset. Okay, you need to add the offset with, okay, add the offset with the value inside of the R1, and then after that you get the new address, go to that address and load the data, put it into the destination register. Okay, what about if you have a 32-bit memory configuration? Okay, so what happens? You just go directly to address 2004, okay, which is at here. Okay, so this is the address 2004 and load the value and put it inside R0. Okay, so these are examples. Okay, we're going to look at the examples. Okay, how the load instruction perform. Okay, we assume that, okay, let's say this is a register bank. Okay, and this is the what we call here the memory. Okay, we use the 8-bit memory configuration. Okay, this is a memory and this is a register. Okay, assume this is a R5 and then you have R7 down here, right? And then the address here is started from 4200. Okay, I call this address is 4200. Okay, because it's easy rather than saying it's using a million. Okay, 40,200,000. Okay, so I put a 4000 followed by the next value is a 200. Okay, 4200 is somewhere around here. 200. And it is a, sorry. Okay, so this one is 4200. Then followed by address 4201. Okay, and then followed by 4202, and last one here is 4203. Okay, let's copy this first. Okay, now assume that inside of this address 4200 until 4203, we have this value 358228115. Okay, so this is a 8-bit memory configuration. How I know that this is a 8-bit memory configuration? Okay, by looking at the difference between the memory address. Okay, the difference only 1 byte. Okay, so you know that it's a 8-bit memory configuration. Right. So the what we call here this the instruction that you're going to execute is this LDR R7, R5. Okay, so what happened here? So first, we assume that R5 is have this value here, but this value 4000 followed by 200. Okay, so what happened? Go to the register R5. Okay, go to R5, and this R5 says that, okay, so you need to go to the address 4200. So the CPU will find the address 4200, which is here. Okay, so this is the address 4200. And then since this is a LDR, LDR means that you need to get 32-bit number. Okay, so the CPU will take 32-bit number. Okay, started with 15 followed by 28, A2 and C5, and then after that going to put it inside R7. Okay, so what is the value that will be put to inside of R7? Okay, since we are using a little Indian. Okay, what is the little Indian mean? Okay, the least significant address will be put to the least significant byte of register. So that's why you can see here 15 will be put first, followed by 28, A2, and C5. Okay, so this is how we load the data, okay, by using this instruction. LDR R7, comma, bracket R5. Okay, that is for 32-bit number. Okay, what about if you're going to load 8-bit number? Okay, so to load the 8-bit number, okay, we are going to use the LDRB. Okay, load a register byte. So the LDRB instruction, load a byte, which is a 8-bit, from the memory and put the value add to the lower byte of the register. Okay, so that's why since we only have 8 bits, so in the register we only put it at bit 0 to bit 7. Okay, least significant byte. And what about the rest? We zero extending it because we know the size of the register is 32-bit, but we only load 8-bit number. What about the rest of the register bit? Okay, just fill up with 0. Okay, similar to the LDR instruction. Okay, you will have a load LDRB RDRN without an offset and with an offset. So this will be the syntax lah. LDRDB, okay, followed by the destination register and okay, the source, okay, source address, okay, where you're going to get the data. Okay, if the offset is 0, means that okay, no need to add with the value and the offset lah to your RN. Okay, if you have an offset plus 4, for example, 2 minus 4, okay, then you need to okay get the new address, go to that new address, load the value, put back to the destination register. Okay, contoh. I give you a contoh here. Okay, the same thing. Okay, so we have this. Right? So the instruction here is a LDRB R7 R5 and assume that R5 is located at same address 4200. Okay, 4200. Okay, I make it bigger. Okay, so easy for us to see. Right. So inside here, the same value lah here. We have 1, 5. Okay, I just use the same value, C5A2. Okay, C5A2 followed by 2815. Okay, so now we're going to look at how this thing works. Okay, so this is the instruction LDRB R7 R5. So what happened? Okay, first we go to the R5. Okay, so R5 pointed to this address 4200. What happened? The CPU will go to address 4200. So this is the address 4200, and now it's going to load the value. Okay, load the data from this address. Okay, and since the instruction is LDRB, okay, a byte of data. So what happened? Instead of take 32-bit number, okay, previously we take all the 32-bit from address 4200 until 4203. But now we only going to take this bit. Okay, this byte, okay, only 8-bit number need to put into R7. Okay, so what value that will be stored to R7? Okay, so here we take this 15 only because it is a byte. Okay, go to R7. So 15 will be there. What about the rest of the bit? Okay, because we know that the size of the register is 32-bit. Okay. So what about the rest? Okay, just fill up with 0. Okay, so this will be the value. Okay, what about this number here? Okay, this number just ignore lah. Tak perlu ambil pun tak apa. Tak perlu ambil. Okay, we only going to load this number. Okay, put it to the register. Okay, so this is what the LTRB instruction do. Any question up until here? Ada soalan tak from you guys? If no question, okay, next we move to, okay, before that, okay, I put another way, okay, another examples lah, okay, so LDRB, okay, R9, okay, then after that, R5 offset, hashtag 2, hashtag 2, for example. Right, so what happened? Okay, so in these examples here, okay, we have an instruction LDRB R9 R5 followed by hashtag 2. So we go to R5. So this is a R5 4200, but now we have an offset 2. So what happened? We need to find a new value of R5. The new address, which is 4202. Okay, so this is after you add with the offset. Okay, now what are we going to do? Go to address 4202. So this is the address, and get the value A2 and put it to R9. Okay, since this is a still B, byte. Okay, so that's why we only take A2 and put it to R9. So R9 now will have A2, and the rest of the bit will be filled up by 0. Okay, so that is for LDRB. Next, we are going to look at the LDRH. Okay, load register half word. Okay, so in this LDRH, okay, we're going to load a 60-bit from the memory and put the value to the lower half word of register from bit 0 to bit 50, and the rest of the bit will be 0 extending. Okay, you just fill up with a 0 from bit 16 to bit 31. Okay, so of the syntax masih lagi sama, same. Okay, LDRH RD followed by bracket RN, comma, hashtag offset if you have an offset. Okay, if you doesn't have an offset, then after that, just simply write LDRH RD bracket R. Okay, so let's look at these examples. Okay, so this is the instructions. It says that LDRH R7 R5. Okay, so what this instruction do? Okay, first you go to R5. So this is R5. Okay, so R5 pointed to the address 4200. Okay, locate the address 4200 in the memory. Okay, from that memory, now how many data that you need to load? Okay, since this is a cache half word, which is 16-bit. So 16-bit means that you need to take 2 bytes of data, started with address 4200 until 4201. Okay, then after that, from here, put it to R7. Okay, once you put it to R7, your R7 will have 15280000. The rest of the bit we just extending with 0. Okay, don't put 1528 here. Okay, if you put this, then wrong lah. Your jawapan will be wrong. Or don't put 15 here followed by 28 there. Also wrong. So this, we are not using a big Indian. We are using a little Indian. Okay, so the correct value will be 2815. Okay, after we take a 32-bit number. Okay, so we got a 32-bit number and put it to R7. Okay, let's say, okay, now another example. Okay, LDRH R7 R5 hashtag 1. What happened here? Okay, so first you go to R5. So this will be your R5. Okay, then after that, this R5 here, you need to add with the offset. Okay, then you get the new R5. The new R5 will be 4,000, okay, 201. Okay, go to address 4,201, which is here. And then take 16-bit number. Okay, 16-bit number, put it to R7. Okay, so now your R7 will be, okay, so this will be our new value of R7 lah. Okay, it will be A228. Okay, because you take a 16-bit number from here and put it to R7. Okay, and then what about your R5? Does your R5 change its value? Okay, if this one here, R5 still same. Okay, no change to your R5 value. Okay, unless you use this R7 5. Then after that, your R5 will change. Okay, your R5 will take a new value. Okay, later we'll see. This is a pre-index. Yang ni kita akan tengok pada pre-index addressing mode. Okay, now we only look at the immediate addressing mode. Okay, you need to know how the immediate addressing mode perform. Then after that, we go to the more apa ni kita panggil challenging part or more advanced, which is using the immediate addressing mode. Sorry, using the index addressing mode. Okay, any question up until here? Ada soalan tak from you guys? Okay. Next is the LDRSB. Okay, load register with a sign byte. So the LDRSB instruction load a sign byte, which is 8-bit data, from the memory and put the value to the lower part of the register. And then after that, we sign extended it. Okay, look at the sign. Okay, number, what value it is. If the sign value is a 0, then you extend with a 0 lah. Okay, the rest of the bit from bit 8 to bit 31, you fill up with 0. If the sign bit is 1, then after that you need to extend with 1. Okay. Do we have examples? Okay, no examples. Okay, I just put the examples here. Okay, assume that the instruction is like this, LDRSB. Okay, and then R7 followed by R5. And the next one is a LDRSB R9 with the R5 hashtag 2. Okay. Okay, let's look at the first instruction. What happened to your R7? Okay, what value that your R7 will get? Okay, so first we go to R5. Okay, so this will be the R5 4200. Locate the address 4200 inside of the memory, and then load the value. Okay, since it says that byte, okay, so we take only 8-bit data. Okay, put it inside here. Okay, and then next we are going to look at this. Okay, next we are going to sign extending it. Okay, how to sign extending it? Okay, so what you need to do? Okay, you need to change lah this value 15 into binary representation. Okay, by using the F4 to 1 method. 15 is actually a 1. Okay, 5 is a 101. Okay, so this will be the value. Okay, 0001 followed by 0101. Then after that, we look at this bit. Sign bit always at the most significant bit lah. Okay, so this will be your sign bit. Okay, and since the sign bit is a 0, so what happened? Okay, you just put a 0 there. Extend with a 0. Okay, so R7 will have 0x00000001 5. So this will be the R7. Okay, what about the next one? R9. Okay, what will be your R9 value? Okay, again, same thing. You go to address to register R5, but this one we have an offset 2. So what we need to do? Okay, we need to get a new address lah. Okay, we change the new address will be 4202. Okay, so go to address 4202. So this is the address 4202. Okay, and load the value. How many bit that you're going to load? 8-bit data. Okay, why 8-bit? Okay, because this is a sign S B. Okay, load 8-bit data A2, put it to R9. Okay, let's say like this R9. So A2 will be there. Okay, then after that, sign extending it. Okay, what value that we need to extend? Is it a 1 or is it a 0? Okay, so what happened? A2, okay, you change A2 to binary representation. A, what is a A? A is a 10. So 8 plus 2 is 10. Okay, the rest is 0. What about 2? 2 will get 1, the rest will 0. Okay, and by looking at this, you need to see here the sign is 1. So what happened? You need to extend the value. Okay, with 1 until bit 31. Okay, then after you did that, the value will be FFFFFA2. Okay, so this will be your R9. 0xFFFFFA2. Okay, any question up until here? Okay, for the LDRH, the same, similar lah to the LDR-SB. Okay, but now, okay, we dealing with a 16-bit, and then sign extending it. Okay, only the lower half, okay, will get the value. The rest of the bit from bit 16 to bit 31, we need to sign extending it. Okay, so this one, it works same with the LDRSB lah. Only that you need to take 16-bit number instead of berapa tadi? 8-bit number. Okay. So any question before we go to the next instruction? Store instruction. Ada soalan tak untuk load instruction? Okay, any question for the load instruction? Load instruction, we have a total of 5 instructions lah. Okay, we have the LDR for 32-bit, LDRB for 8-bit number, LDRH for 60-bit number, then followed by LDRSB for the sign byte, and LDRSH for the sign half word. Okay, this is how you're going to load the data from memory and put it to the general purpose register, the GPR, the register inside ARM processor. Any question up until? Am I too fast? Okay, if I'm too fast, okay, if you're going to slow down, okay, do let me know. Okay, so I will slow down a little bit. Okay, if no question, then we move on to STR. Okay, store register. Okay, so STR instruction will store a 32-bit from register to memory. Now we're going to send the data from register and store it inside of the memory. So this is what the STR do. Okay, similar to what we call load instruction. Okay, we have store with an offset and store without an offset. So this is the syntax. Okay, str rt followed by rn comma hashtag offset. Okay, so rt is the source register. Okay, previously is a destination, is it? So now it become source, and D is where you're going to store the destination, the address that you're going to store. So every time you see the bracket here, okay, the bracket means that it pointed to the memory location, okay, the memory address. Okay, so this bracket is actually pointed, okay, we need to go to this memory address. Okay, without the bracket means that, okay, the data will be coming from your register. Okay, this is how to differentiate between the RD with a bracket, okay, between the register with a bracket and register without a bracket. Register without a bracket is inside of the register lah. Register with a bracket is actually inside of the memory. Okay, you need to go to that memory location pointed by the register. All right, so let's look at this example. Okay, so I just copy paste the previous one. Same thing. Okay, now kat sini, okay, I'm going to erase this one lah. Okay, tak apa. Kalau ada pun tak apa. Okay, no problem. Okay, if the value is there also no problem. Okay, we just put it that way. Alright. So sekarang ni dia kata STR. Okay, R3 R6. So this is the instruction. Okay, so I just change here. This one is R6 and R3 is here. Let's say the value inside of R3 is 1, 2, 3, 4, 5, 6, 7, and 8. So this is the value inside of R3. Okay. So what happens to this instruction? Okay, you have str R3 bracket R6. So what happened? Okay, R3, as we know, this is where you is your source. R6 is the destination. So what happened here is you're going to store the value from R3 and put it inside of the register memory. Okay, so since R6 pointed to address 4200, so what happened here? Okay, we go to address 4200. Okay, so this is the address 4200. Then we're going to store this value from R3. Okay, from R3, store the value in here. Okay, how many bit that you're going to store? 32-bit, because this is STR. STR is a 32-bit number. Okay, you're going to store a 32-bit number. Okay, so now inside of this address 4,200 until 4,203, we have a value. So what happened to this value? Okay, this value will be override, okay, by a new value. Okay, so the new value will be stored will be 78, 56, 34, and 12. Okay, remember D is a little Indian. Okay, if you're using the big Indian, then after that, the value that will be stored here will be 1, 2, 3, 4, 5, 6, and 7, 8. Okay, so this is a big Indian, but we are now using a little Indian. Okay, so little Indian means that the low significant bit, the LSB, okay, the least significant byte, okay, will be stored at the least address, okay, at the smallest address. Okay, while the most significant byte will be stored at the higher address. Okay, so this is how the STR instruction is performed. Okay, let's say another ni lah contoh. I give you another contoh. Okay, STR R3 hashtag R6 STR R3 bracket R6 hashtags -2. Okay, now we got an idea. So what happened here? Anyone want to help me? Oh. So what happened? All right. So this is the thing. Okay, so first, okay, you go to R6. Okay, and this is R6 value, 4,200. And then 4,200, you see here, you need to minus with 2. Okay, so 4,000, okay, 200 minus with 2. Okay, and you will get 4,000. Okay, somebody please press the calculator. I'm afraid that I put this wrong. And E so FF. Okay, is it a correct address? 4,001 FD after we minus with 2. Anyone can verify it? Boleh tak? Can somebody verify the value here? The value, is it the value is correct or not? Okay, you have a 4,000,0200 minus with 2. Okay. Betul tak? By using the calculator. FE or FD? FE, eh? Alright, so FE. Right, so here, this is address 4,011F is here. Okay, then after that, we have, okay, here, then we have, here is a 4,011E is here, followed by 4,011D. Sorry, ini F ya, FE, FD. Alright, is here. Okay, so this is the address. Okay, after you minus with 1, you will get this address, the following address before the 4,200. Okay, you minus with 1, you will get 4,001FF. Then after that, 4,001FF, 1FE, and 4,001FD. Okay, so now what happened? Okay, we need to go to address 4,001FE. Okay, go to address 4,001 FE. So this is the address lah of the 4,001 1FE. Lepas tu nak buat apa? We're going to store the value from R3. Okay, so now the value will, okay, that you will get is 78, will store there, followed by 56. And then here, okay, need to replace with 1, 2, and 3, 4. Okay, 3, 4, and 1, 2. Okay. Okay, that is for the STR. Okay, any question up until here? Okay, I think we just stop here. Okay, for the rest of STRB, STR H, okay, we'll continue in the next class. Okay, any question from you guys? Ada soalan tak?